are so many sectors in the world that are using the knowledge from brain sciences in order to better understand us. Education is one of the last. Healthcare is not so good at the moment. But how come education that has the teacher, the knowledge, that is training people, that has access to academic research, how come we're not using this knowledge in order to improve content and format, for example, in the classroom? How so? Well, one of the explanations might be that all the answers are not provided by neuroscience. Guess what? That's true. Neuroscience does not hold all the answers. Fair enough. Name me one science that can give you all the answers. Sociology can't, economics can't, medicine can't. Science is about trial and error. Science is about inventing, being creative in the way we do things. It can be about observing a phenomenon and trying to understand it. Or it can be about thinking about something that does not exist and creating it. So part of a problem today might be that some people are a bit afraid about what neuroscience can say. And by the way, neuroscience doesn't say anything. People say things. A science doesn't say anything. But interpretation. Science is all about interpretation. Because science is ruled and executed by humans. And as soon as you've got humans putting their hands on something, it is biased. And you know what? Bias is fine. I don't know why people want to fight some biases. We need to understand biases. We need to embrace biases. And we need to use biases for the better good. This is what we need to do. Biases are here. You can fight them the way you want. They will still be here. I'm not talking about prejudice and discrimination. I'm talking about cognitive and social biases. Biases are like gravity. Gravity is everywhere, all the time. And you know what? Gravity prevents me from flying right now. But there are a few brilliant minds that invented planes. So I can sit on a plane and I can fly. So similarly, some brilliant minds in behavioral and brain sciences have worked some solutions to use biases for the better good in order to improve the way we learn, for example. So that is one issue. The other issue might be that you cannot put everyone in a brain scan, because for a lot of people, neuroscience means very, very heavy brain scans that cost millions of dollars and that require some expertise and require people to go to medical and scientific facilities. And that's true. Oops, that was true. This is no longer the only option. Of course, those scanners, and this is something called magnetic resonance imaging, are fantastic. We need them. But we don't need them to understand some brain activities. And as you can see, if I want to understand how kids think, decide, or engage in a classroom, it's going to be very difficult to recreate a classroom when people are lying in this scanner. This is why companies like ours have been working over the past 10 years in creating portable solutions, in creating solutions that allow to take neuroscience out of a scientific and medical facilities in order to be able to record, monitor, understand brain activity during our everyday lives. Similarly, that your smartwatch would track your heartbeats. Now we've got wearable devices that can record your brain activity virtually everywhere. But science is science. It's not because you can record something. It's not because you can collect data that you understand things. You have to make sense of the data. You have to create experimental designs, protocols that allow to answer questions. And more importantly, once you have access to devices like this one that allows to record the electric activity of your brain, you need to use it not only to better understand people, but making sure that it doesn't harm and it's done in an ethical way. That the data is used for the better good. So interestingly, these solutions exist. And I will give you a short tour of a couple of applications of use of these devices and the algorithms in the world of education and what we can do with it, and also what the limits are. So these devices allow us to visualize brain activity almost in real time. There is a slight delay, just a delay for the device to send information to your phone. So what it means is that you can walk around, record your brain activity on your phone, access some cloud computing that has machine and deep learning that is fed by all the people that are sharing that data with us. And what we're very good at, for example, is monitoring attention and distraction, fatigue, mental fatigue. Are you starting to picture all of this applied in the classroom? I wish I could monitor all of your brains now in order to see how engaged you are and to try to understand if someone looks not interested, whether it's because of me or because of your digestive system, given the time. Of course, because I'm biased, I will blame it on the food. But the data might say otherwise. And you know what? When I say I wish I could record all your brains, technically it's possible. We can do that. We've done that, multiple brains. But again, I need to have a good scientific question. So here's the thing. When you think about neuroscience and education, neuroscience and learning, what do we want to know that we don't know yet? What could we learn from science, from the combination of behavioral and brain sciences that could help us teach better, that could help us engage kids better? Let me give you an example. Did it ever occur to you that we should vary the length of some classes, that a literature class might not require the same level of intensity of attention as a maths class? Not because one topic is more important than the other, but depending on your personal skills as a teacher, your personal taste as a student. Your engagement might be different. Would it be possible to use wearable devices in order to improve personalized education? The answer is technically yes. But a brain on its own, it's something absolutely useless. If you take the 1.4 kilogram of brain matter and you put it on the table, nothing's going to happen. For a brain to become useful, you need to study, understand how the brain interacts with its environment, the first of which is the body. And bodies matter. Brain matters, but the body matters as well. There are studies that show how important it is to teach movements that are associated with a foreign language. I'm a Frenchman, and we got neighbors across the Alps that speak a lot doing this. Guess what? There are studies that show that if on top of speaking good Italian, you add the gesture that people are used to seeing when people speak, the other people will understand you better. Makes sense, because we're not just brains, we're brains in bodies. And our bodies are interacting with other bodies and with the environment. Environments are plural. Physical, social, and digital. Well, digital is not so much something separate now. It's kind of embedded, and it will be more and more embedded. So, these brains, we need to understand the ecosystem. And it's not because a scientific experiment in the lab is going to show you that a sample of kids, students, adults will memorize better a lesson given a certain context, that you can transfer this automatically in real life and in the classroom. Because in general, what is observed in the lab is part of a story, but the full story happens when we interact with others, when we interact with environments, with fatigue, with what happened the day before, with our history, with our culture. Is it possible to take everything into account into a natural experiment in the classroom? It's going to be very difficult. However, we can try. And we can try and explore some of the factors that participate in learning. So we're working on an entire ecosystem. The ecosystem allows to monitor the brain activity, but it also allows to act on connected devices. It's called brain-computer interfaces. We helped one of my dearest friends, who's quadriplegic, drive a Formula One car with his mind only. You can control things. I recently had the case of someone called Damien in France, who cannot move but can write and send messages because he's using one of our devices interacting with a right algorithm, with a right brain-computer interface. What is interesting is that since we can monitor brain activity in real time, we can do something called neurofeedback. Neurofeedback is the possibility to watch your brain activity and to try to control some parameters. Think about biofeedback. Your heartbeats, again. When you monitor your heartbeat and you're kind of excited and you need to cool down, you're looking at the BPMs, the beats per minute, and you breathe. And you try to calm down. And you've got a feedback telling you whether your heartbeat is going down or up. We can do the same with brain activity. Of course, it's not as straightforward as up, down. But we can represent, in a gamified way, brainwaves, so that kids who have attention disorder see it as a game and can see their progress in real time in calming down, in paying attention to something. It's about the ecosystem. It's not only about measuring, it's about measuring and acting. In psychology, we would talk about the perception and action cycle. Add on top of that the decision. So, the technology is here, finally. For 20 years, almost, I've been hearing, you cannot put everyone in a brain scan, or you can't put a brain scan on everyone. Well, now it's possible. We've got more than 80,000 people in 120 countries that own one of the devices that you see here. A lot of them are sharing anonymously under ethical protocols some of the data with us, and we learn from this data. And from this data, our algorithms are learning to detect when people pay attention or not. And this is something that can be used similarly that you would learn from any other data. So what can we do with this? And should we do it? And who should do it? France, my home country, since the election of President Macron, has been moving towards evidence-informed public policy strategies. And that's very different. I used to work for the French Prime Minister and run for 4 years a program called Neuroscience and Public Policy. And we looked at how we apply neuroscience to fighting obesity, fighting tobacco, questions related to the environment and education. And what is interesting is that I also run experiments, but most of these experiments were not used by policymakers in order to inform policy. Generally, the way policy was conducted before is to take people like me that are identified as experts, whatever that means, to lock us up in a council, a committee, ask us to work for 6 weeks to 6 months and then come up with a report, and this report will inform the minister that will make a decision. Not only in France, in many countries. Yet, the data is lacking, because generally when you write a report, it's about the data that is from way back. So, running experiments, running randomized controlled trials where you test things here and there might help. Might provide you, maybe not with the best solution, but with a least worst solution. Or, a great benefit is to avoid what does not work. Science, and neuroscience is part of it, will never give you what the right thing to do is. Will never tell you this is 100%. But it can be very good at telling you avoid that. Because if we monitor attention, for example, you can see that kids might be very distracted by the way you tell a story. So you know that this is not the right way to tell a story. However, what would be the right way to tell the story would require the expertise from people who are storytellers, maybe marketers. Talking about marketing and consumer behavior when it comes to education, not good, but could help. We should be able to be open to storytellers. Some people are experts in storytelling. They understand our brains better than a lot of people studying the brain are. They understand why we stick to stories, why we're engaged, why, and not only why, but they know how to make you absolutely adore a character in a movie. Should we engineer kids liking their teachers? Maybe not. But should we train teachers so that they know what is a repeller, what is disengaging for kids based on scientific insights? I would say yes. But as I told you at the beginning of my talk, this is my very own and biased opinion, and we will have a Q&A at the end where I hope some of you are going to challenge that. In the meantime, let me tell you a little bit about the fact that we can now record brain activity in classrooms for experiments that are a bit more realistic, a lot more realistic than experiments that are run in brain scans that are requiring people to be alone, not interacting with people. This is a study by Susan Dykers in New York that is using our technology, where she looked at how various configurations allowed to understand how brains synchronize in the classroom, and showed that there is better learning, better engagement when people interact better with each other, when their brains synchronize. France, at the moment, under the leadership of its current Minister of Education, Jean-Michel Blanquer, is on the forefront of trying to use sciences, behavioral and brain sciences, in order to inform education strategy. And inform is a very important word here. It's not decide. It's not evidence-based policy. It's evidence-informed policy. The council, called the Scientific Council of National Education, has been created at the beginning of this year. It's very recent. It's led by one of the most famous neuroscientists in the world, Stanislas Dehaene, who holds the chair of cognitive psychology at the Collège de France. And there are 21 people. Amongst these 21 people, almost a third comes from psychology, behavioral, and brain sciences. Then there are specialists of the science of education, ethics, philosophy, sociology. The goal is to understand how we can bring some of the knowledge that is found in the labs and apply it in the classroom. But also, and that's important, how can we take some insights from the classroom to inspire scientific experiment in order to test some of the intuition, some of the experience of the teachers? Because here we're not talking about science dictating how education should be in the coming years. No, it's science helping improve what works best, correct what doesn't work, and maybe provide creative ways for people to learn, especially in an environment that is changing and changing and changing. Look around us. Most of you are teachers. The way you've been teaching the past 10 years is going to change in the next 10 years because when you look at the world, the workplace, everything is changing. I belong to a generation that doesn't do so many transitions from one sector, from one job to another. The kids that are starting school these days are very likely to have multiple careers in multiple sectors. First thing. Second, their interaction with technology is absolutely amazing, with incredible benefits, and some people would say danger. Think about learning foreign languages. Google just released a couple of earphones that allow you to have a real-time translation of 40 foreign languages. Does this mean that kids should stop learning foreign languages? My opinion is no, absolutely not, never. Keep on learning foreign languages. However, for parents, maybe instead of choosing which language your kid is going to learn, which foreign language, instead of choosing it based on statistics, the most spoken languages in the world, English, Spanish, Mandarin, French, etc., maybe it's no longer a matter of stats. Maybe it's just a matter of diversity. Maybe what matters most is to learn different languages, be it ancient Gaelic, Provençal, Catalan. As long as your kid is going to learn a couple of languages so that brain plasticity does its job, so that the brain learns to adapt, learns to learn, then you'll be efficient with your translator, with your implanted chip or whatever you're going to have in the next 10 years that will allow you to understand everyone and everything. However, some factors will still remain. The body. I'm still waiting, but it might come, for the earphones to allow me or to make me do the right movement when I speak the foreign language. So, amongst the topics that are of interest in neuroscience research, you've got attention, I mentioned, but motivation as well. Motivation, there are people who are experts in motivation. Teachers are in schools, or some of them, but for a lot of them, depending on where they work, it's quite a challenge because they are very motivated, and in front of them, there might be some people that are not so motivated. A couple of governments are working with people who are training professional athletes, who are training people who have a bad accident and that are trying to relearn to live. Understanding the motivation. I personally learned tons on motivation with my friend Mark Pollock. Mark is a friend who became blind early in his life and later broke his spine and is now in a wheelchair. And Mark has been an inspiration because from the day he woke up after his accident that cost him the ability to walk, he said, I will walk again. And his motivation has never faded. And there is so much we can learn from Mark, and so much we can learn from the strategies that Mark has developed in his mind, and then test them into the lab and run them through experts in education to see whether we can use some of the things that Mark is suggesting in the classroom. Maybe not. But the key is also to start looking somewhere else, to pick up information. And neuroscience is part of that. And I insist, it is part of a scientific knowledge that can inform. I that should inform education. Learning. There is so much about learning. So much in neuroscience. And there is mixed data. It ranges from understanding how we stabilize connections in the brain when we learn new patterns, to better understanding what are the right times for people to learn. Remember, for some reason, if you've ever opened or read a book about the brain and cognitive functions, very often people talk about high executive functions and low level, so high level cognition and low level motor and body. High level cognitive functions are like memorizing, doing mental computation, etc., etc. And somehow, some people talk about low level motor activity. Okay, so now tell me, how come a kid, a toddler, learns to speak only after they learn to walk and interact with the world, for most of them? You don't learn to speak for many reasons, the brain development, etc., just laying on a bed. You interact with the world, you touch, you fall, you smell. And then, language, the language, speaking. There are much more. And we know that from neuroscience, from psychology and beyond. There is much more than speaking in language. Language, we saw, can form the way you think, can inform the way you think, can determine somehow how you will learn later. And this is where it's getting interesting, is the ability to monitor learning mechanisms, learning strategies, to test things, to test, to learn, and to adapt, and to test again, to learn, and to adapt. Or, that's the creative scientific way, or to observe, tweak, test, learn, adapt, repeat. Another interesting thing that we're going to have to deal with in the future is to unlearn things. Because there is everything that we learn when we're kids, and as I mentioned, in the future, we might need to learn other things. A great example comes from sports. Roger Federer, arguably the best tennis player in history, had plateaued, and everyone was thinking his career was declining. And somehow he unlearned his back shot and learned a new way and started to win again. He spent time unlearning what he had practiced for years and years and years. Started almost from scratch. After all, he's Roger Federer, so I would say that he doesn't restart tennis from scratch, but you get the picture. So people might say, he's an exceptional being. He is. But what does exceptional mean? From a neuroscience point of view, we're all exceptional. We're all exceptions because there is no normative brain. It's so banal to say that all brains are different, but all interactions are different. So experiments in the classroom allow to understand how people memorize, how they pay attention, and as importantly, how they interact with each other. For all of you that I've taught, you know that if there is a leader in the classroom that has decided that he or she will disrupt your class, you're going to have a hard time for the next 2 hours. If you understand when people disengage from what you say, by measuring their brain activity, by tracking where they're looking, you might be able, well, to vary a little bit, be it cracking a joke, giving them a break, asking them to draw instead of just listen or do some maths, vary things. We got ways to measure. And intentionally today, I'm not throwing at you neuroscientific results, because that would be only a partial biased view of a story. Not because the scientific studies are bad, but it will be my selection, what my interest is. What I hope to convince you about today is how important it is to use new ways to measure and understand the behavior of students, of teachers, and of parents, anyone in the ecosystem that contributes to education. Friends. A few words about the future. The DARPA is an agency run by the US government that is at the top of the game of innovation, but geared towards improving everything related to the Army. DARPA is working since 2016 on a program that aims at uploading some knowledge in people's minds, at creating and facilitating learning by triggering nerves at the periphery, so on the body, in order to foster the release of biochemical messengers and create new connections in the brain. That is one vision of a future. And just like we're trying to improve every sector, this is one of it. Learning. Of course, in that case, it will be to learn skills that people in operations, in military operations, will be able to apply. But there is also something to take from there. The fact that a lot of sectors for their executive education, for preparing the troops, for understanding why we buy things, why we stick or not to a treatment, why we crave the next episode after seeing the cliffhanger at the end of a show. All of them at the moment are using behavioral and brain insights. And I insist on behavioral and brain insights in order to better understand this. And it's about time that for neuroscience to be embraced by education, not because I'm saying it, but because it will provide some added value. I'm going to stop here and finish on one point. One of the key issues with technologies this day is they can contribute to provide people with access to information, access to content, access to knowledge, but also it can create more and more gaps because some people will have access to technology and some people will not. And one thing that Tanli, the person who founded Emotive, has in mind, and she'll never, never give up until it's achieved, is to provide access to brain health care to the underserved. There are so many countries at the moment that do not have access to these big brain scans that I showed at the beginning. What we're trying to do is not only to manufacture the most portable, reliable technology to record brain activity. And when I say reliable, it's because we've got more than 4,000 publications that are using and backing up what we're doing, using our technology. It's not only, it doesn't have to be only scalable, reliable. It has to be affordable. And we have started a program that we are self-funding where we seed little labs in underserved areas. In some areas, we're doing early detection of mental conditions, brain health. In other areas, we're monitoring cognitive declines. Cognitive declines, plural, because there might be a cognitive decline because you're getting old. That's the natural and unsurprising for most of you way to lose some of your cognitive abilities. But a kid in a refugee camp, after a couple of years, has a cognitive decline. Instead of learning, there is a decline in cognition. A person who loses her job and stops seeking for a job and starts spending days in front of TV because some people give up, because it's hard, because they no longer have the money to travel around and go for interview. A person that is in mid-30s might show signs of cognitive decline that we would normally see in people over 60. All of these things can be monitored. But in order to monitor and see the benefits of science, we need to provide access to technology to the biggest amount of people. And this is what we're trying to do with many partners. We're trying to create public-private partnerships, and education is part of it. So we are running this global alliance for access to brain healthcare. And if you're interested, I'm more than happy to talk about it. So, in conclusion, as you heard, and I think I made it very clear in my very biased presentation, I strongly advocate for considering neuroscientific insights in education, to informing policy with behavioral and brain insights collected in experiments that are run in classrooms, that are run in the most natural environments, in order to better understand the brains of real people in their real lives. And these people are, of course, the students, of course, the teachers, but everyone that is contributing to the lives of the teachers, the students, and that are influencing their lives. Never forget, brain matters. Thank you very much. And we have time for questions. Is there a second mic, please?
Yes, hi. I have. My name is Ulrike from Guide and Lead here. Hi. Very practical question, actually. So we see in schools a lot that the kids have lower motor skills, leading to problems in writing and learning, cognitive issues in general. So at school, we try to expose them to different materials like messy play and stuff like this. But obviously, we cannot do what is missed out of school when the kids are just dealing with gadgets and smooth surfaces and so on. Do you see that there will be gadgets from your company or alike that actually could help us to close the gap that the kids are missing out?
I think the best gadget is the human body.
Sure, of course.
Yeah, and this is that gadget that we're underusing. There is data showing that you can learn better with touch. And not just because you're learning about anatomy, for example. Of course, if you've got a plastic bone, you'll understand better how by touching it, by manipulating it, you'll understand better anatomy. But counting on your fingers, it's interesting. For example, there is a very interesting experiment reporting that some of the best students in an age group in Western countries, it's always a sample. When I'm not going to repeat it all the time, but every time I'm talking about an experiment, unless there is a massive amount of participants, it's always a limited sample, but yet gives an indication. The best students were actually counting on their fingers. Does this mean that we need to teach everyone that you should use your fingers to count? No. As of practically, what should be happening is also using metaphors and mental images. Metaphors are not only cognitive ways to facilitate the understanding of things. Metaphors are rooted in our body. We imagine and we picture metaphors that are related to how we perceive our body and how we perceive the interaction of our body in the environment. For example, you know, when we say something is going up or down, it's always related. It's not even a metaphor. It's just an image, an analogy. But okay, your results are up, but up is related to my body reference. Something as simple as that. So I think there will be more and more devices that will allow interaction, more accurate interaction with touch, smell, maybe taste. We worked a little bit on that. Audio. It's the multisensory aspect of things that is going to help. But at the moment, there is very few technology that is using this multisensory beyond vision, touch, and sound. And at the moment, when you think about the way we use touch to swipe, to press, this is very limited. Vibration can help, feedbacks. So I welcome ideas. Something tells me you got ideas that you're going to share with me afterwards on how to use multisensory integration, how our brain is integrating all this information in order to better understand and better teach.
It's going to be a long talk.
Well, that will be payback for the long talk I just gave you. Thank you. Sir, ask first and then. Sir.
Hi, thank you very much. Incredible stuff. But the visualizations you had with the brain floating around and all the lights flashing look very beautiful, but are completely kind of incomprehensible. What kind of data are you actually getting out, and how easy is it? How easy is that for people to actually interpret? I mean, if I'm a teacher and I'm trying to understand how my students are interacting, or how they, how they're experiencing a lesson, what do I get out of the device that I can actually use as feedback?
Just like any data, if I show you data from heart measures or body temperature without explaining what the unit is and how it's been collected, it doesn't make any sense. And this is what I meant by making sense of the data. For example, you will relate the findings and some of the location of the activity to what we've learned in previous experiments that are more, I would say, more laboratory experiments. For example, when you see activity that is peaking in the back of your brain, you might interpret that as the fact that your student is using a visual strategy for things, which makes sense if a student is reading. But you might see visual activity when people are imagining things. And your way to imagine the solution to a math problem, a geometry problem in mind, might be different. You might be a very visual person, and I would understand part of it from the brain activity. And I might be someone who's totally processing this in an abstract way. And by finding this information, by being able to interpret the relative activity from the prefrontal activity that might be related to some sort of attention and planning, the fact that somehow, if you identify early in the process of learning a brain network that is related to paying attention, and you see that there is a decrease of activity in this brain network, you might draw the conclusion that some process has been automatized, that is less relying on thinking, processing, but more on, getting used to what you did. So these are the ways to do it. It's really relying on what we know from the lab and some of the knowledge that we're going to learn from the natural experiments, because there is so much we don't know, starting with social interactions. When it comes to problem solving, it's easy to recreate a problem solving, when I say problem, mathematical problem, geometry problem, to recreate it in the lab and to run one person after the other in the experiment and draw some conclusions. But what is going on when you've got your friend next to you in school that solves a problem in 2 minutes and you're still scratching your head? Choking mechanisms that are very well known in psychology. How do they express themselves in the brain? Is there a neuromarker? And if we identify this neuromarker, can we develop a strategy in order to help the kid cope with it based on what we measure, etc., etc.? So it's always this kind of back and forth, constant back and forth between the observation, the measure of a behavior, of movement, and what brain adds on top of it. And it's important, as I mentioned, adds on top of it.
Yeah, I just think it's important to make sure that it's as accessible to teachers as possible, or to the people using it. You don't want every teacher to be a neuroscientist and trying.
Absolutely not. And I think we are in the future zone. All the devices are there. You can come and experiment them, play with them, see what's easy, what's not so easy. But I think what we've worked great, we spend a lot of time working on is not just creating the hardware technology that collects the best data, that is affordable and reliable, but also create interfaces that are very simple. You'll see that you'll be able to fly a drone with your mind with an interface that you can use to control your Lego, your TV, etc. Is making it simple. And I think that you put the finger on the main thing. Is we're talking about education, about engaging students, etc. It's the same thing with technology. There is a brand with an apple in its logo that has done a fantastic job at creating devices that we can use in a sub-second. We take them, and it's very intuitive. And you might move to another device, and it's not as intuitive because they understood. And we're trying to do that. But I would say our job is a little bit more complicated than allowing you to text and to place a phone call. There's someone here, please, and then behind. Okay, go ahead.
So I'm fascinated by the transformation of classroom design. I think that classrooms tend to interfere with learning. What does the neuroscience say about classroom design?
I have to be consistent with what I said before. So neuroscience says nothing. Neuroscientist, however, here's the thing, is for me, everything is design. And I work all the time with designers. And the idea is spatial configuration, which is something that is of interest for people who are still fighting about open space versus closed offices. The idea is that there is more and more evidence that a fixed configuration for the entire year is not what's best. Similarly, that when you have a big dinner party, it's good to say, hey, let's switch seats. First, switching seats, of course. But then, changing colors, changing lighting. So, of course, these are like, yeah, sure, we're going to change lighting in classrooms. But there are other sectors that did it. There is a kids' hospital in Lake Nona in Florida that allowed kids just to have in their hospital room, they can change the color of a lights at night. And it has a tremendous impact on their well-being. So, of course, we don't want every kid to be able to change the color of a lights while you're teaching, because next thing you know, they're going to bring a couple of decks and a mixer, and it's going to turn into a dance floor, which can be fun, by the way, because that's part of a design. See, I have this strong bias, like most of us, that when you spoke about design, I thought about interior design, about thick things. Design is also about human design. It's about how you somehow engineer the social interactions based on what we know from social sciences. And I consider neuroscience as a behavioral and a social science, just for the record. And this is what's important as well, is to be able to vary and to, because there are many different definitions of intelligence, whatever that means, but the one skill, let's go on to skills, given the theme of the forum, the one skill that is important is to be able to adapt. And you can only adapt if you're facing change. It sounds so obvious and dull to say it. However, we're teaching kids that are sitting in a lot of countries, in a lot of places, on the same chair next to the same person for an entire year without any change in whatever is surrounding them. So I know that in the education world, speaking about engineering social interaction is making people cringe. But please, when it comes from me, please see it with the best intentions, is fostering diversity. Diversity in the interaction itself, in the content, in the people you talk to. Because if it doesn't happen naturally, then you got to help. And it might not be an invisible hand, it might be a scientific hand, it might be a teacher's hand. As long as all these hands hold each other and work in unison, I think we're on the right track.
Yeah.
Oh, all right. Yeah.
May I go?
Yes, please
Oh,
go
thank
ahead,
you.
sir. And
Yeah.
can you please bring the microphone for the lady here? Thank you.
Yeah. I worked for a system about 15 years ago that had a software program, and I do recall the name, but I'm not going to use it. But it was basically a treatment for ADHD, where the helmet back 15 years ago wasn't nearly as cool as yours. It was pretty much, it covered the whole head.
Sure.
The idea was to focus, keep a character in a certain position on the screen.
Yes.
In the time since then, has there been research done to show that transfers to another setting other than make this figure dance in front of you a certain way? And does that translate to the classroom? Is there research show that that's effective? And because to me, if the child is focusing on this dolphin from drowning, which is kind of morbid, but I do recall, but then how do you remind that student when he's in math class to, hey, don't let this occur? Could you expand on that a little or speak to that?
Yes, absolutely. So just drifting away to come back, it's just like if you pump iron in the gym in order to prepare for your boxing game, and you just pump iron. If no one is giving you and sharing and teaching you the right technique to throw a punch, you can pump all the iron in the world, it's not going to help. So if you do just neurofeedback for the sake of neurofeedback, without anyone telling you afterwards, you see, the strategy that you used in order to save a dolphin in your example, or to do something else in more advanced games, then how can you use this in real life? How can you think about this sensation that you had to control your body, to control the way you breathe, etc.? It's always about taking technology and making it human. A lot of people are talking about human-centric design these days. It's kind of a buzzword, but it's so important. And I think this is where we come from, is from the setup that you described that is very, very scientific in a way. It's not super user-friendly, to something that is almost a game. Because you want the kids that have attention disorders and that need to spend an hour a day on an interface, on a software, on a device. You want them to be engaged and to really be happy to do it. And part of it is not just what they are doing during that hour, is how they are going to picture and experience the benefits afterwards. And I think that's the key, is to be able to show progress. And this is what was lacking before. And now, with the help of people who design games, the fact that everything that we offer, but others as well, is on a tablet, is on a phone, which is a very friendly environment for kids, maybe too friendly, but yet let's leverage their, I wouldn't say love for their cell phone, but at least the pleasure they take in using it, their engagement, in order to use that. And that's part of the learnings, as I mentioned earlier, about user experience, about whether you like it or not, whether I like it or not, my kids are consuming things. They are consuming content at school, sometimes learning from it, sometimes just learning by heart because the system is not well designed in France, at least in their school, and they forget after the test. And for me, this is exactly the same as consuming a soda. You got temporary benefits, but afterwards, you don't.
Okay.
One more after you, then I
Okay.
think we have to to go.
Just a quick question. As a teacher, I'm really interested in the results of this research. But for me, scientists seem to be so far away. How do you encourage these professionals go back to school? How do you encourage this collaboration between scientists and education on the level of school and teaching?
This is one of the reasons I left academia. Is one of my big pleasure is to go to school, and for two reasons, and to talk to kids and teachers, because these are the hardest questions. I've been trained my entire life to handle questions from fellow scientists. I know how to do that. Oh, I can be grilled, you know, it's easy. But questions from kids, questions from people who are dealing, again, with real issues on a daily basis is what makes us create products that are more user-friendly and that are more useful. And I think one of the problem with scientists, and I'm speaking as a scientist now, is that most of the time we complain and say, people don't listen to us, etc. Well, start speaking the language of people and maybe people are going to listen to you. I mean, I think there is more asked from the science world to be acknowledged as contributing to improving the state of the world. So if, as a scientist, I'm the one asking for validation, recognition, whatever it is, I should be the one making an effort to communicate. And I think that one of the things that is missing there, when we're trained in academia, I was a professor at university, is we never taught how to speak to real humans. We're taught to speak to students who are real humans outside the classroom. But for most academic people, in front of them, they are just listening machines. Learning machines at best, but listening machines, not humans. And that's part of the issue. But this is also where you guys have a role in being teachers, in saying, okay, this is how I understand things, in asking questions. All right, when you say this bit connects with this bit in the brain, is it the same thing as sharing analogies, sharing metaphors, so that people move toward each other? But I'm not saying this, I'm saying this as a former teacher, because I started teaching young kids and then all the kids at university. But scientists have to make the effort. Because a lot of science in a lot of countries is still subsidized by government. And as such, there is a duty for this science to be useful for the people who pay taxes, for the citizens. And similarly, that parents have a role in the education of their kids, and it's not just the responsibility of the teachers. Scientists have a role in advocating, promoting, translating, and making their findings more understandable. And I'm not talking about applied science, it's just being able to speak about what you do, I hope in a simple manner. Simple, yet not simplistic. One last question. I think it's, they want to record us. This is why. Yeah, I would have loved to do the talk without a mic as well.
That's fine, okay. So you cited the study of Dicker and Purple, and they collected the data from students why they were not moving and not talking because of the fact that with the muscles, the electricity is higher than the electricity in our brains. So, but if I talk to my students and tell them not to move and not to talk and just to think, this won't work in my classroom. Do you see any possibility to use your devices, which are great, but to use them in classroom with normal activities like talking, moving, and stuff? Yeah.
So just to be clear, the study I mentioned, so that everyone understands, used our technology, but the older version. So for those who are not familiar with what we record, is we record the electric activity. So there are two kinds of electric activity that you can pick up when you put electrodes on the head. Is electric activity from the brain, but also electric activity from the muscles. And for a long time, it's been a problem to distinguish what comes from the muscles and what comes from the brain. Our new algorithms do that great. So basically, They pick up the electric activity of the brain and separate it from the muscular activity of the facial muscles. And this is why our devices not only record brain activity, they record also, they can identify some facial expressions. So this is the next step. And actually, the next step to the study you mentioned, which is the current step in what we offer, it also records movements of the head, which is very important when you measure attention. Because what is important, and especially when you couple it with tracking where the eyes are looking at what you're reading, is you can look at me for an hour and think about something else. But if I just use what is called eye tracking, then if I use eye tracking, you're looking at me, I'm like, oh, she's engaged, she likes what. But if I put the headset on and I see that there is in the algorithm we have to combine this with the visual cortex, that there is no visual attention, then you're busted. I know you're thinking about what you're doing next. Now, I can't say whether it's next or before, but I know that you're not listening to me. And that's the evolution. And it's going to go more and more about it. But don't get me wrong, it's never going to be clear-cut, because there will always be so many interactions in the present or occurring in the classroom, but also the interaction of all the consequences of having a fight with your parents the night before, or not sleeping, or for all the parents in the room, not sleeping because your kid was sick, so then you don't sleep, you're worried, and you have to go to school, etc., etc. But it's getting better. I think we're done with time. Thank you so much for your attention. And you're most welcome to come to the Future Zone, where we'll transform you in Jedis in a few seconds to fly a drone, and you'll be able also to see your brain activity. Thanks a lot.